Alright, well today what we're going to do is we're going to look at how to inspect some common sensor problems that you might occur on your Genesis Coupe. For today what we're going to look at is O2 sensor, injector, map sensor, and injector coil. Or not injector coil, ignition coil. Alright, so the tools you're going to need for this are pretty simple. You only need to know how to unplug your sensor. They do not need to come out of the vehicle. You just need to unplug them. And a multimeter. So that's it. To access your ignition coil, you need a 10 millimeter bolt ratchet in order to take the RS Turbo logo thing off the top of the engine. So there. Now, what you do is you start off with your multimeter. Now, some people prefer analog, some people prefer digital, because digital is easier to read. In my experience, I use a digital for everything that is low, and I use an analog for everything that's high. So the other thing you're going to need is you're going to need your tech manual. Now, if you don't have a tech manual, there's going to be a link in the bottom that has a that you click on it, and you'll be able to download the tech manual directly off my SkyDrive, and that's always up, so you should have no issues getting it. The first section of the tech manual that you're going to need is you are going to need the engine electrical system, and that is to find out what you need to do with this. Now, 2013, this is all going to be based off of a 2010. So 2013 owners, I'm going to put the correct values right here for what you guys do, but the process is the same. So I guess technically you don't need your tech manual, but it's a good thing to have anyways. So we're going to start with your ignition coil, or some people know them as a coil over pack, or there's lots of different names for them. Now you got two resistances on your ignition coil. You've got your primary resistance and you've got your secondary resistance. Secondary resistance is measuring between the device down here in the bottom and neutral, so your chassis or whatever. Outside of the vehicle, this is really hard to test because you're not making a circuit. And it's best to have this plugged in when you're doing this. Alright? So we're just going to focus on whether or not this top part here is dead rather than that. Okay? So to test this, we start off looking for a value of 0.62 ohms plus or minus 10%. So set your multimeter as low as possible. Mine only goes down to 200. And you want to work in the range that you're looking for, okay? Alright. So it's important to know how to do this correctly. Looking at the injector, now this is my number 4 injector, obviously. You got two pins in there. This side is positive. This side is negative. So, with your leads connected black to common and red to low voltage, resistance, and milliamp, just for those of you who are not familiar with using one of these, you take your red terminal or probe and we touch it to the positive. Sorry, this is going to be difficult to see here. And then we take our black probe and we touch it to there. And this is saying this particular one fluctuating all over the place. Got good, nice contact. And it's saying 0.8. So we have more resistance than we should. If we can get a better contact here. Yeah, 0.8. And we're looking for 0.62 plus or minus 10%. So the most we'd be looking at is 0.7 as an acceptable value. I'm going to grab a different coil and we're going to test that one as well. Alright, so we've got the number 3. Same method as before. And it's saying 0.8 as well. So either my meter's inaccurate or this thing's bad too. But either way, they're consistent. So that's really important to know. And more than likely, it's perfectly fine because these things here are not 100% accurate, to be perfectly honest. And this meter doesn't go below 200 ohms. I'd prefer if it went to 20 ohms. But we're going to continue on anyways. So that's how to test your ignition coil. Next thing on the list is we will be looking at the map sensor. This is a 4-pin map sensor. And you know that it's a map sensor because it's got the thermal probe. Or the one on the cylinder because it's got a thermal probe. So let's look up the specs in the manual. Okay, now for these next components, you have a little bit of an issue. The manuals that you need is the engine control system manual. However, it's 790 something pages. So if you do print it, make sure you print it on both sides of the paper, save some trees. But what you only really need is pages 1 through 94, okay? And that'll give you, for sensors, everything you need to test. For the pressure aspect of the sensor, there's no real test because we're looking at a voltage change. It produces a voltage. So we can't really test that aspect, but we can test the temperature probe. So according to Hyundai, the inspection procedure is to connect a scan tool on the data link connector, which is underneath your dash, and measure the voltage of the output voltage of the map sensor at idle and ignition on. Okay, so at idle, we would be looking at roughly half a volt. With ignition on, it should say 0. Okay, so how do we measure that? Well, here's the sensor, and you see those 4 pins. Going from the outside, it is 1, 2, 3, 4. Okay, so to measure the voltage with this connected, you have to look at the harness and either poke your probes in to the back side of the harness, or you use what's called a split connect, and it is a harness adapter that plugs into here and then plugs into the harness, and it's got a little doohickey hanging out of it, and you put your probes in there. Oops, sorry. I don't own one of those, and my engine doesn't run, so I can't show you how to do that. But what I can show you is which one we are measuring, and we are measuring pin 1 and pin 3. So you would be measuring that far pin and that pin right there. Okay? So that one and that one. Now with your intake air temperature sensor, which is this little probe thing here, we are measuring the resistance between terminals 3 and 4. So we are measuring 3 and 4, which doesn't look right to me, but whatever. So we will put the positive on there. We will put the negative on there. Sorry, this is kind of fidgety to do. And we get nothing. Absolutely nothing, which is wrong. Let's try reversing these. Interesting. See, I know my air temperature sensor works. Okay, well, maybe this sensor needs to be plugged in order for it to work. Either way, you have labeling across here, 1, 2, 3, 4, and you also have a little number here which says 2.5, and that's how many bar the sensor is. Okay, so that one doesn't look like we can test that one outside of the vehicle. So we will continue on to the O2 sensor. Okay, so with your O2 sensor, you cannot actually verify that the sensor itself is working correctly without an oscilloscope. Okay, and I don't have one. So all we can do is make sure that the heater built in is working correctly. And to do that, we have to look at this. And none of Hyundai's diagrams match what my sensor is. So, and this is a Hyundai sensor. Let's see if there's any markings on here. None, but we got a gray wire, a black wire, and 2 white wires. So we will just have to figure it out. Now, to make sure that the heater is working, we measure the resistance between terminals 3 and 4. Check to make sure that the resistance is within specification. Now, what resistance are we looking for? We are looking for 3.3 to 4.1 ohms at 21 degrees Celsius. Okay, so since this should only produce resistance on the heater, 3 and 4. Now, see, it says measure the resistance between 3 and 4, but in the actual picture layout, 3 and 4 would be main relay and heater control, not sensor ground. Okay, so 3 and 4 should be the bottom two.
I'd say this is it. So.
Okay, I've got the sensor upside down. So it's measuring 3.9. So the heater on this sensor is perfectly fine. And why is the heater important? Well, the heater is important because it pre-warms the O2 sensor in order to bring the sensor up to temperature, which allows it to operate correctly, because they have to be at a certain temperature in order to perform their job correctly. So if your heater in this is garbage, then your sensor will not work correctly until the sensor gets up to temperature. So it will cause rough idle until it warms up. It will cause a bunch of other stuff. So you really don't. This would be garbage if that came to pass. So which ones did we measure? Looking at the plug this way, you know, these two sharp clippy things here, and you got a long body retainer there. You're looking at the bottom two. Yeah, pretty sure. If the pokies are at the top, it's the bottom two. Yep. So, pokies at the top, bottom two. Now I believe for 2011 they made a change to a 5-pin O2 sensor, and that means that the O2 sensor is actually a wideband, which explains the significant cost difference between a 2010 and a 2011 O2 sensor. So 2011 owners, be prepared that if you have to replace your O2 sensor, it's going to cost quite a bit more. And again, you can only test the heater of the sensor. So there. That is O2 sensor. Map sensor's done. Not much we can do on that. So all we're left with is injector. So I'll pull up the diagram for the injector and then we will continue. Alright, now the injector is really easy because you only have 2 wires. You have, again, the picture doesn't match. Either way, according to the wiring diagram, you have a diode in there anyways. So one is positive, one is negative, and we'll find out which one is which, because it does not show. Oh, positive is this side, so positive is here, negative is there. Now, the color of your injectors, Hyundai has several colors of injectors, and they don't seem to make any difference. Sorry, just reading some numbers on it. There's blue bodies, there's green bodies, there's gray bodies, black bodies, and I think that's it. And why they changed the color of the plastics, I have no idea. Probably cost. Whatever color was cheapest at the time, who knows? But they all flow the same up until 2013. So, and they're all inspected the same up until 2013. Actually, in 2013 they're inspected as well, but there's a different resistance for them, and that's right there. So let's get on to testing. We have, this is a cylinder 1 injector. Put the positive to the positive, and the negative to the negative, and it is showing 15.4 ohms. Now, coil resistance at 20 degrees Celsius should be between 13.8 and 15.2, which again is different for 2013s. And I'm reading 15.4, but it is also higher than 20 degrees Celsius right now. So the injector resistance is perfectly fine for this one. And that is how you check it. Now, if you want to get the injector down to exactly 20 degrees, you need to use a thermal probe, or not a thermal probe, but a a laser temperature indicator, which is a little red dot will show up somewhere, and you just point and go beep, and it tells you what the temperature is. And you want to take the temperature from that surface right there where the 4 pintle holes are, okay, or spray pattern holes. And you can stick this in your fridge and then just keep checking the temperature of that part there until it gets down to 20 degrees, and then quickly measure here. Because I know some people don't live in climates that it ever gets to 20 degrees, basically. So that's how you inspect these. Now, there are a lot of different temperature sensors and pressure sensors and all sorts of stuff all throughout your block. You got your NOx sensor, and you've got your oil control valve sensor, and your fuel control valve sensor, your fuel pressure sensor. Lots and lots of sensors, and that's what pages 1 to 94 in the engine control system section of the manual covers, is all those different injectors or sensors. The only thing is that we run into is you need special equipment in order to test some of them. You need an oscilloscope to test your certain things correctly. And for those of you that are not familiar with an oscilloscope, it is a device that reads a lot of different things, but is primarily used for determining frequencies, okay, or pulses. That's basically all frequencies are. And when you're looking in your book, you know you need an oscilloscope when you see one of these. Okay, and that's giving you the pattern that you should be seeing on your oscilloscope, and it gives you your resolutions and everything that you need to be looking at, which for Hyundai's is pretty much stops at 5 volts. There's a certain things go up to 14.4, so make sure that that's the range your oscilloscope will go to. But it also needs to go negative that low as well, okay? Because some things run on negative voltage, and I'm not going to get into that. It's the easiest way to say it is it runs on negative voltage. So you're looking for these waveforms, these patterns, okay? And in order to do that, you need an oscilloscope. Certain things like your NOx sensor require a different tool for measuring capacitance, and without that special tool, you have no way of measuring how much capacitance the NOx sensor can hold, or power it can contain, because it's a capacitor. And without that tool, you can't figure that out. Okay, so certain tools you may need to rent or borrow or buy in order to test all of your sensors correctly. So make sure that if that's what you're trying to do, is sort all this stuff out, that you have all the proper equipment in order to do it. But that's basically how you test sensors, and make sure that you either use the PDF format of the book and a tablet to skim through it, or, because I'm old-fashioned, I like paper. I have a printed copy of my entire shop manual that I keep, well, several books of these that I keep in order to diagnose and rebuild stuff. So, hope this helps some people, and I hope this helps people solve some of their issues as they go through their vehicles, and talk to you guys later.